All right, B7, right? So B7, what I have depicted right here is a radial probability distribution for an orbital, right? I don't give you any information on what type of orbital it is, what the end level is or any of that stuff, right? You can, you know, again, using kind of principles that I talked about when I was talking about the actual, 3D figures of of the orbitals. You can use a lot of that information to get as much info as possible. In those instances. So in this case right here, right, looking at it, we can see that there's two humps, right? We have one lower energy one, right, where you have a node that exists at the origin, as you would expect, right? And then you have a node that's not at, 0, right, that you have that's about, right, 2.5, AOs away from the nucleus, right? And then you have a larger hump, and then it kind of plateaus and it just goes away. One thing that a lot of people confused, right, is that they think like, oh, there's a radial node out here, right, because this is getting down to 0. That is not true. There's never a terminal radial node, right, because technically this is never going to reach 0. It's going to keep on going to infinity. Right, that like it's not right. It's going to asymptote out, using math terms. Um, or vernacular. Right. And so that's the thing to think about and look at for that right there. Right. So there's technically, just simply two different nodes that are present. There's one radial node, right? Because there's this one node right here. Let me change the color. Right. This right here is the radial node because it's not at 0, it's further out. And so now in this question right here, right, it says if the total number of nodes equals 3, what type of orbital is it? Draw the orbital, right? So if we know that this right here, right, we have one radial node, then that tells us that the total number of nodes, right, they're going to be equal to 3, right? And that's equal to the number of angular nodes and the number of radial nodes in that case. And so if we know then that we have one radial node, right, just by simply looking at this, what we can then say, right, is that the number of angular nodes is going to be equal to 3 minus 1. And so that equals 2. And so then that means then that because we have two angular nodes, that L is equal to 2. And from that, we know then that the L equals 2 orbital is going to be equal to the d orbitals, right? And so this is going to be a d orbital right here in this case. And so now the next thing, right, that we have to think about is, well, okay, well, what's the n value, right? Because that then will tell us, what type of orbital we have. And so because we have total of 3 number of nodes, and so then 3 plus 1 gives us then that n is equal to 4. That tells us, right, that we should be drawing a 4d orbital in this case. Now, one thing to point out, right, is that there's two different style looking orbitals for the 4D. One of them is the dz squared, right, where you're primarily along the z-axis, and that is not really going to probably look like no, actually, I guess it could. Right. I mean, it would be perfectly fine, I think, to actually do that. In my mind, right, I would just jump straight to like the 4dxz, the 4dxy, right? And so then to draw that, right, you draw, for any of the d orbitals, right, you always draw like the 4-leaf clover, right? And then you shade those different regions. That right there is the 3D. And then now, right, because we're actually not at the 3D, right, we're at the 4D, we have the radial node that's around it. We just simply draw, right, the little hats that are of like the opposite phase on top of them, right? And so that right there is then the 4D orbital in that case, right? So you can see the radial node, right, where you have that invisible sphere that cuts the lobes in those cases. And then you can still see that you have the angular nodes that designate that it's a d orbital in this case, right? And so that's what, for part B. So for part C, right, it says if the total number of nodes is equal to 4, what type of orbital is it? So in this case, right, then we're going to have 4 minus 1 gives us 3, right, which is going to be our L value in that case. And so that tells us then that what we're looking at is an F orbital in this case. And so it's going to have to be a 5F. And so then again, right, you would just simply draw, the F orbitals. And so there's, the one that looks like this right here, where you have then the shading. I'm trying to see, did I not include a picture? I probably didn't. I may have forgotten. This is B7. Yeah. I mean, you can just draw your own, right? And then you just simply put the little hats on them. Right? And just make sure that the shading matches what it should be. Right? And so that right there, right? Those are two different possibilities that you could have just by looking at the radial probability distribution in those cases, for that. So yeah, so that's how you do B7. Does the pen work?